Now in textbooks, they're given this way sometimes. Other times they may just say angle B is and side A is, find the other sides. But what we're going to do is list it in this form. So we're given an angle of a right triangle. We're given a side of a right triangle. What we want to do is to find the other parts of that right triangle. Now basically in this tape and in most problems they deal with the right angle being the angle C, and they call the other angles A and B. And it does not make any difference where you call this A and this B, just whatever side A, angle A is, then the side opposite that is little a. Angle B, the side opposite that is little b, and the side opposite the angle C is small c. So when we have the A, B, and C, then this means this is the side opposite the angle A, this is the side opposite the angle B, and so on and so forth. All right, the first step is if they give you an angle of a right triangle, one of the acute angles, then you can find the other one by simply subtracting this angle from 90 degrees. So that's no problem. That's not part of this concept in the trig book. You know that already, right? Now the thing I want you to pay attention to in these notes is sometimes I put 45 degrees and 50 minutes down because that's what textbooks have. Nowadays with calculators you should just switch that over to decimals, and the way you do that is simply divide this by 60. So you take your calculator and 50 divided by 60 and then plus 45, and that gives you your 45.8333 decimal value. That's one way. Many calculators have a conversion factor that you can convert that over. So I talk about that in another tape also. So therefore we find angle B. Now when we find angle B, then we can find side B. Okay. Now let's see. All right, we have angle B up here. Angle B is 45.8333 degrees. And we want to find angle B. Now listen to me closely. I'm going to show you two different ways of approaching this. One way is to do this. Let's just try the sine. The sine of angle B is a side opposite over the oops, that's two unknowns. That didn't work. So I'll try the cosine. The cosine of angle B is the side adjacent over, well, that's not what we're looking for. So I'll try the tangent. The tangent of 45.833 degrees is equal to the side opposite, which is B, over the side adjacent, which we know. And we have two known values and only one unknown. So therefore you can use tangent. What I'm saying to you is when you're first starting out, you just trial and error. Try the sine of the angle, try the cosine of the angle, try the tangent of the angle. All right, that's one way. Now the other way, and this is the way you should do it after you pick up one or two problems in practice, is you go through mental process of saying, what's the sine of this? Well, that's that. No. This is opposite, and this is adjacent. I know this one. I know this. I don't know that. Opposite, adjacent. Opposite, adjacent is tangent. So therefore you start out with tangent. All right, that's the first concept that I want to teach about the process. The second concept is this. If the unknown is here, then you find it by cross multiplying. So therefore B is 0.700 times the tangent of 45.8. Now, the reason I put that little mark up there is to say that this is a repeating decimal. Whatever the mark is over repeats. So that's 8333333 forever. Now, what you should do, as I've said in other tapes, is when you do that 50 divided by 60 plus 45 and you get that, then store it. And then recall it each time, and you have an exact value, correct, 8 or 10 decimal places. All right, so the process here then is if the unknown is up here, then we cross multiply and we get the answer. Now, why have I written down the 0.700 rather than just writing down 0.7? Well, the only purpose in that is saying, the textbook is saying I want the answer correct at 3 decimal places. So therefore you go calculate it. If the problem had 0.7, then the answer in the back of the book would have been probably correct to 1 decimal place. No, forget that. You have calculators nowadays. That's old-fashioned. Write it down. Write down 2 or 3 decimal places because you have that accuracy now. All right, now we want to find side C. All right, so I'll erase this and we'll look at find side C. Well, let's do the shortcut. We know this to be 0.7, so we have adjacent hypotenuse. Well, let's see, that's cosine in it. So the cosine of 45.833 degrees is the side adjacent, which is 0.7, over the hypotenuse, which is C. Second teaching process in this problem. If the unknown is in the denominator, you switch places with it. So you put 0.7 divided by the cosine of 45 degrees. So it's a very quick technique. If the unknown's up here, you cross multiply. If the unknown is here, you replace and divide. All right, and you get decimal value there. Now, check your work. Check your work by the Pythagorean theorem. Take the answer that we have to be, square it, plus this 0.7, square it, and it should equal to C squared. Now you should ask, well, when I found B, why didn't I just do this squared plus this squared and go find C squared? Well, here's a caution. There's nothing wrong with that, but there's a caution here, and that is you should always use numbers given in the problem and not what you calculate. If you miss B, then you automatically miss C. So at all possible, always use values that are given to calculate an unknown. It's not always possible in all problems, but try to stay by that rule if possible. All right, so that's the calculation of B and C and angle A. So let's look at the second example. Okay, the second example gives us A, B, C. We got 2 of those 3 letters. So therefore we can use A squared plus B squared is equal to C squared. Now again, remembering now, C is supposed to be always opposite the 90-degree angle. It's the hypotenuse. It's the largest side. So therefore this is why the C is here and the A and B are over here. Well, therefore we simply do 363 squared plus B squared is equal to 4 squared. So we get B squared is equal to 2.82. Again, this is rounded off in the notes. You have a calculator. You can carry all this correct in the calculator, and when you take the square root of that, we end up getting 1.68. Okay, why 0.68? Because these are written correct at 2 decimal places, so we'll round it off, so we'll have it correct at 2 decimal places. All right, so we found B. We found it by using just the Pythagorean theorem. All right, now let's look at the triangle to find the angles. Now again, we found B, but we're not going to use it because we could have made a mistake in there. All right, so we'll just use these. If I want angle A. Now let's see, angle A, this is opposite, that's sine. So the sine of angle A is the side opposite over the side adjacent. And so we end up calculating that. All right, so the calculation of that is 0.9075. The sine of A is 0.9075. What we want to find is what is angle A. Okay, what is angle A? Now this is where you'll use your calculator and hit second sine button, or in other words, find the inverse sine button. And so you'll do the inverse sine of 0.9075. Now what that'll give us is a decimal answer. Okay, that gives us an answer of 65 point something. Right. If you'll notice the notes on the TI-85, if you put this behind your calculation, so if you come over here and put DMS behind it, go find that underneath math, then it will give this correct to minutes and seconds. Okay, degrees, minutes, seconds. So whichever way your teacher wants or the textbook wants is what you need to work. So anyway, this will then be 65 degrees in 10 minutes. Okay, now to check your work, two ways. Finding B is simply what? 90 degrees minus this. So you can subtract that. Another way to check it, do that also, but another way to check it, come up here and let's find B. Okay, so let's see, angle B. Angle B, this is adjacent hypotenuse. That means that's the cosine, is the adjacent. All right, so then we want to do the inverse cosine of this 0.9075, this divided by that. Okay, so we'll go do the inverse cosine button, and we should get what is called a complement of that 6510. And that's a way of double checking your work. All right, let's look at number 3. Okay. Number 3 is just another way of writing it. In the notes it says angle A is 19.2666 degrees, and side A is 3.78. Find the other sides, or the other parts, or find just one part. Okay, so let's just say that we want to find just the part C. We're not looking for everything in this time. They give us this, they give us that, go find that particular part of the triangle. Well, that's a very simple process. Here's an angle. This is what? Opposite. This is a hypotenuse. Okay, and that's the sine of 19.266 degrees is equal to the side opposite over the hypotenuse. Therefore, C is equal to 3.78 divided by the sine of 19.266. And so you calculate C and get that answer. All right, one other statement on this, and then we'll look at applications of using this process. What I'm trying to say to you is when we have right triangles, somewhere in some problem, and you have a lot of this in trig, and you use that concept for physics and for engineering statics, and that is you're given two parts of a right triangle. You want to find the third part. So you're either going to use sine, cosine, or tangent. And the reason you need to use those three is you have buttons on the calculator. No need to deal with secant, cosecant, cotangent. Deal with sine, cosine, or tangent. And what's going to happen is you're going to use either sine, cosine, or tangent that will give you 2 out of the 3 unknown values there. So pick out which trig function that will solve this by letting us only have one unknown letter in the problem. And then I also pointed out the concept, if the unknown's here, then you switch places and divide. If the unknown's here, you cross multiply. If the angle that you're looking for, the unknown is here, then you will divide this out, change it into a decimal, and then take your calculator and hit the inverse function of this, of that decimal value, and it gives you the angle. All right, let's look at some other examples now. Boy. Example 4 says this: the height of the Sears Tower in Chicago. Find that height. If the angle of elevation of its top from a point on the ground, 1,177 feet from its base, is 51. Read it again. You need to learn to read stated problems 2 or 3 times until you have a feeling for what they have to say rather than just slapping numbers around. Find the height of the Sears Tower in Chicago from a point on the ground. All right, so here's the tower, and here's the ground. We're coming over here from at 1177 feet, and we're looking up and sighting the top of that, and this angle is 51. Now wait a minute, angle of elevation. Angle of elevation is what is the angle from a horizontal position or line up to something. Angle of elevation is the angle measured from a horizontal line up to whatever you're viewing or what's seeing or measuring. So the angle of elevation is 51 degrees from the horizontal. All right, so we read the problem and we draw the figure. So it's a right triangle. We know this to be 1177, and we have an angle, and we want to find that. Now, watch out. Now, I'm going to be using x's in here for unknowns, not the old x, y, z concept, but just an x to represent the unknown. I'm not going to use a, b's, and c's. I'm going to say, all right, this side is 1177, and here's the angle, and I want to find that side. All right, so that's the side the unknown, so I'll use the letter x. All right. So, what do we have? This is opposite and adjacent, so that's tangent. So we'll then come down and say the tangent of 51 degrees is x over 1177. Therefore, x is equal to 1177 times the tangent of 51 degrees. And that is 1,454 feet. Now, I want to talk about something. The answer to this is 1454. Okay, round it off. This is whole numbers, so we'll round it off to whole numbers. The tangent of 45 degrees is 1. 45 degrees says if this is 1177, this will be 1177. If this angle is larger than 45 degrees, then this side is going to be larger than this side. If this angle is smaller than 45 degrees, this is going to be smaller than that. You should double check your work. You should make sense of your answers, okay? The largest side is opposite the largest angle, so that's the largest side. The next largest side is opposite the next largest angle, okay? And so this side has to be greater than that side. Double check your work of problems as a reasoning process. All right, now let's look at example 5. Example 5 says a 20-foot ladder rests against a vertical wall with its foot on the level ground and 11 feet from the base of the wall. What is the angle? Let's see, wait a minute. A 20-foot ladder rests against a vertical wall. All right, so here's the ladder against the wall. Okay, and it says vertical. What is that for? Well, that's just words to make sure that we do a right angle. And it says on level ground, so that says this ground has to be level. All those words are for is saying to us this is a right triangle. Right? So, and it says what is the angle the ladder makes with the wall? That would be this angle, not this one. This would be the angle the ladder makes with the floor or the ground. So we're looking for that angle. So we read the problem several times, if necessary, to get the figure and fill in all the numbers and the letters that we're looking for, okay? So this time we're looking for the angle. Well, let's see. Here's the angle. This is what? This is side opposite. That's what? Sine. So the sine of theta is equal to the side opposite over the hypotenuse. Okay, and therefore we find the theta by doing the inverse sine button, okay, of 11 over 20. So we do the inverse sine of 0.55 and find that angle. Okay, very simple little problem, but the point is, here we have a simple problem that's a right triangle. We're given two parts of it. We want to find a third part. And so we're going to either use sine, cosine, or tangent. All right, example 6. It says the Royal Gorge Bridge crosses the Arkansas River near Cannon City, Colorado. That's interesting. That's just talk. From a point 900 feet from the same horizontal plane with, here we have to read that again. From a point 900 feet in the same horizontal, well, here's what this is saying. Here's the bridge, and so 900 feet away from the bridge, horizontally. So 900 feet away from the bridge, horizontally. The angle of depression, angle of depression. Angle of depression is going down, the measurement down. So what that's saying is, we're over here at 900 feet from the bridge, looking straight at the bridge, and then we look down this many degrees and see the river. Okay? So with some kind of measurement instruments, call it transit, we do that kind of measurement. So let me read the sentence again. All right, from a point 900 feet in a horizontal plane from the bridge, we measure an angle of depression of 49.4833 degrees and sight the river. And the question is, what is the distance from the bridge to the river? All right, so that's our unknown. This is what we're trying to find. Well, let's see. This is side opposite, side adjacent. So that's tangent. So we'll do the tangent of 49.4833 degrees is equal to the side opposite over side adjacent. Therefore, x is equal to 900 times the tangent of 49.4833. And so we get 1,053 feet. So that means the river is 1,053 feet below the bridge. Again, examples of, given some kind of figure, right triangle, then we can go find a missing side of it or a missing angle of it by either sine, cosine, or tangent. All right, now let's look at example 7. Now example 7 has another concept that's involved, and that's bearing, percent grade for engineers, okay? So this one says Akron, Ohio is 100 miles due north of Charleston, West Virginia. So we'll use C for Charleston and A for Akron, all right? So Akron, Ohio is 190 miles due north, straight up from Charleston. Okay, we got that. Stamford, Connecticut is due east of Akron. Oh, okay. Stamford, Connecticut is due east of Akron and is 460 miles from Charleston. So we get to put the 460 here. Now you got to be real careful and read those 2 or 3 times to make sure you get the right numbers and the right directions on these things. So let's double check it one more time. Akron is 190 miles due north of Charleston. That's good. Stamford, Connecticut is due east. It's over here. But then the 460 doesn't say that's 460. It says Stamford is 460 from Charleston. So the 460 goes there. Then it asks, what is the compass bearing of Stamford from Charleston? What is the compass bearing of Stamford, which means we're going this direction? What is the compass bearing of Stamford from Charleston? If it had read, what is the compass bearing of Charleston from Stamford, then we've been going this direction. So it's extremely important we know which direction we're talking about. All right, compass bearing. Compass bearing requires us to know north some degrees west, or north so many degrees east, or southwest, or southeast. Now what these angles are, listen closely, is the angle it makes with the north-south line. The angle it makes with the north-south line. Other words, if I'm going out this direction, then it would be north this many degrees west. This would be north so many degrees east. This would be south so many degrees west. This would be south so many degrees. We do not measure up and down. We measure the angle it makes with the north-south line. Therefore, that's the key to this compass bearing problems and these textbook problems. Therefore, if we want the compass bearing of Stanford from Connecticut, we need that angle. And it would be north this many degrees east. Now, if we wanted a compass bearing of Charleston from Stanford, then we would have to go find this angle outside the triangle. Well, it happens to be the same as this, but that's the concept is it's the angle it makes with a north-south line. Okay, either south, west, southeast, northwest, northeast. So therefore, our answer is going to be north, theta, east. So we've got to go find theta and fill that in and answer the problem. So we'll do that. Well, let's see. Here's the angle, and this is adjacent hypotenuse. That's cosine. So therefore, we want to do the cosine of theta is equal to adjacent over hypotenuse. And so we find that angle. So we punch the button and find the inverse cosine button of 190 divided by 460. Now, what I have in the notes I want you to see on tape, and that is you don't have to divide this out and go write that down. Do all this in one step. Come along here and say, well, theta is the inverse cosine. That's, second cosine button. And then you just put parentheses, 190 divided by 460, and then enter. And it gives you the answer, okay? And that way you don't have to go through writing down decimals, rounding off, not saving it, or whatever. Just go do all of that in one step. So therefore, and that answer is 65.6. Therefore, the answer to the problem is north 65.6 degrees east. All right, let's look now at example 8. Now, example 8 says the sides of an isosceles triangle. Isosceles triangle. Isosceles triangle means two sides are equal. And that also means, it doesn't say it that way, but it also implies that if these two sides are equal, these two angles are equal. Right? So this angle is equal to that angle. Also from plane geometry in high school is that if you draw the line from the vertex down perpendicular to the base, it will divide it into half. So what we have now is a right triangle over here or a right triangle over here, whichever side we want to work, where we're given an angle that we're looking for, a side, and a side. See, this is now 3 because that altitude, that perpendicular bisector, okay, bit of an isosceles triangle. So it divides this into half. So this is 3, this is 8. Hey, we've got 2 known numbers, so we can find a third number. Or we can go up here and find this angle, okay? Whatever angle we're looking for. It says find the angle of a triangle. So we'll just start out with this one and use it, but we could find that one. So whichever one we want to do. All right, so we read the problem, we draw it, and then we sit around and try to figure out some kind of a right triangle, and then we go work it. All right, here we go. Let's see, we're looking for this angle, so this is adjacent, so let's forget this over here. What we're saying is we're looking at this triangle, okay, right here. So the adjacent That's it. And that's, oops, okay, so that's cosine. So we'll do the cosine, all right? Cosine of theta is side adjacent over the hypotenuse. Therefore, theta is what now? Let's do it all in one step. Theta is the inverse cosine of 3 divided by 8, enter. Okay? And we get that to be 68 degrees. 68 degrees. Just round it off, all right? All right, now let's go back and look at the entire triangle. Okay? So going back and looking at the entire triangle, this is 68 degrees. What does this mean? Well, that means this is 68 degrees. And therefore, what we can do is add these two together, subtract 180 to find the third angle. All right? So that's what I mean in the notes by how 180 minus 2 times this equals 44 degrees for that top angle. Now, you could have done the problem this way. You could have come up here and found this angle. Okay, this would have been 22 degrees. So you double that and get your 44, subtract it from 180, take half of that, and you'll get each one of those angles. So whatever reasoning process. The trig is just these two simple steps that's involved. Okay, let's look now at the last two examples. All right, number 9 now. Here's one where we need to read and understand for a while before we do a lot of stuff. I have a kind of a figure there, but let's kind of read the problem. It says, a plane leaves an airport at 9 a.m. and flies southwest. Okay, well, leaves the airplane and flies southwest. So we're going southwest, all right? 45 degrees. Exactly southwest is 45 degrees, so that's where I come up with that. So that's 45 degrees there. And the second plane leaves the airport at 9:30 and flies northwest. Northwest is exactly 45 degrees that direction. At 320 miles per hour. Find the bearing of the second plane from the first plane at 10 o'clock. Wait a minute now. We got all these time things in here. So it says a plane goes this direction for a while, and this plane's going that direction for a while, and what we want to know is the bearing of this second plane from the first plane. So what this dotted line right here is representing is our north-south line. We want to measure off this angle this way, or this way, or that way. So here's the one we're looking for. This is the bearing of the second plane from the first plane. Well, wait a minute. Since this is 45 and that's 45 and that's 90, then that makes that 90. So that means this is a right triangle. So we get to use a right triangle process. Well, the theta, this angle is not even in the triangle. So hey, this is 45. If this is 45, then this one's 45. So if we'll go find this angle of the triangle, add it to 45, subtract all that from 90, we'll find the angle we're looking for. So what we're going to do is go to the triangle now and find this angle. Okay, well, let's see. Now we need these sides in terms of miles or feet or inches. So we got to do some calculation now. Let's see what all this means. 9 o'clock, 9:30, and 10 o'clock. Well, let's read the problem. A plane leaves an airport at 9 a.m. and flies southwest at 200 miles an hour. So this one's going 200 miles an hour. For how long? Well, we read down in the third sentence. It says, find the bearing at 10 o'clock. Let's see. This one left at 9. So 10 o'clock is 1 hour. So that's 200 miles per hour. Therefore, this side is 200. Okay, got to read the problem again. A second plane leaves at 9:30. At 9:30, and we want to know what happens at 10 o'clock. That's 30 minutes. That's half an hour. This plane is traveling 320 miles per hour, so we go half an hour. Therefore, this distance is 160. So this side's 160 and this side's 200, and now we can go find the angle. All right, so a lot of reading and a lot of thinking and other calculations before we finally get to trig, which is, let's see, here's the angle, this is opposite, adjacent. Therefore, we're going to do the tangent of this angle is equal to 160 over 200. So therefore, theta is the inverse tangent of 0.8. Okay? And that's 39 degrees. So theta, this angle right here, whatever you want to call it, A, B, C, this is 39. Therefore, I'm going to add 39 to 45, and that's how much? That's 84 degrees. So all of this angle right here, all of this angle is 84 degrees. Therefore, this leaves 6 degrees. So the final answer is north 60 degrees east. North 60 degrees east. Okay, so, and this is typical where you use trig in other math classes. Other math classes, you may have other things involved, but when you finally get down to a right triangle and you know two parts of it, then you can find other parts of it. But you don't necessarily use that as the final answer. That's not the final answer. We now use that angle and go in and do some algebra and concepts of 9 degrees, subtract, and we get the final answer of the problem. All right, let's look now at the last example, number 10. Okay, so from a point, the angle of elevation of a mountain peak is 27 degrees. From point B in the same horizontal plane with A and 12 feet closer to the base of the angle. Yeah, we got to go read it again. Now, you know, in the tape, you just look up there and have it drawn for you. But you're going to probably have to read this several times to get what it's saying. It's saying from a point A, all right, so here's point A, the angle of elevation. So we're going to look up and see the top of the mountain peak. Okay. All right, then it says from a point B in the same horizontal plane. Well, that's just simply saying we've got to do this to have a right triangle. And 1,320 feet closer. So the distance from here to here is 1,300, okay, closer to the base of the mountain. So this closer, then from here we look up and it forms a 34 degree angle. And it says now we want to find the height of the mountain. So what we're trying to find is what y is equal to. Listen closely, what y is equal to. Now to get that, we're going to probably have to go find an x first, and then we'll use x and 34 degrees and get y. Okay? So we don't just go get y to start off with. All right. Well, we have two right triangles. We have this triangle and we have the outside large triangle. All right. So what can we say? Well, we can take some trig concepts. Let's take the inside triangle. The inside triangle is, let's see, this is opposite, adjacent. So all right, that's tangent. So we can say the tangent of 34 degrees is equal to the side opposite over the side adjacent. Now we're solving for y, so therefore y is equal to x times the tangent of 34 degrees. Okay. Well, let's take the outside triangle. Okay. The outside triangle is the tangent of 27 degrees is equal to the side opposite over the side adjacent, which is 1320 plus x. All right. So for this outside triangle, it's the side opposite, which is y, over x distance plus 13. This total distance is x plus 13. Well, solving for y, we have 1320 plus x times the tangent of 27 degrees. Oh, great, look, look, look. Y is equal to this, y is equal to that. So we can say this is equal to that. So we can come down and say 1320 plus x times the tangent of 27 degrees, which is 0.5095. That's equal to. That is y. This is equal to the tangent 34. Tangent 34 is 0.6745x. Tangent of this is 0.6745 times x. Oh, we've got an equation with x, so we can go solve for x. All right, so solving for x, let's see. This times this is 672.5. Okay. And then this times x is 0.5095x equals 0.6745x. All right, so leaving this 672.5 and coming over and subtracting this, we get 0.1650x. And so x is equal to this divided by that, which is 4,076. All right. Now, that's not what we're looking for. Always remember what the problem is asking to find. The problem is asking to find y. So I guess the easiest one then would be coming right back here. Come right back in here to this statement. Okay? And let's move over here and look at that again. So we have the tangent 34 was 0.6745. X is equal to y. So all we have to do is do 645 times that 4076. And so y then, final answer comes out to be 2749 feet. All right. Now what I've done on these problems is to try to show you examples that you read in your textbook. Okay. Well, while I was doing that, I was trying to get across the concept of how you use side opposite, side adjacent, sine, cosine, or tangent to go find a third part of a right triangle. This concludes in tape 231.